Hello, this is Jim Schaefer, executive producer and host of Rip Rap, the academic book television program. My guest today is Ben Orlove. Today we'll be discussing the book that he co-edited with Alan Wiegand and Brian H. Luckman. The book is Darkening Peaks, Glacier Retreat, Science and Society. Welcome to Rip Rap, Ben.
Thanks, good to be here.
As I told you before, this is a really interesting book, and it seems particularly timely with all the issues going on with global warming. But perhaps you can explain about how glaciers have a well-established place in our natural and cultural landscape.
Sure, I think there's a lot of attention now to glaciers because, as you say, they're so connected to global warming, but it's been in human awareness around the world that high mountain peaks have ice high on them. And that's something certainly that was a strong part of European culture, the notion that the Alps had their icy summits, that the northern parts of Norway also had a lot of ice, and it's certainly one of the things that the explorers discovered as they covered North America. Of course, the glaciers are mostly in the western U.S., but the explorers coming down the Pacific coast, even in the 1700s, saw these enormous white summits in the middle of the summer as they were coming down what's now British Columbia and Washington State. They saw those that impressed the explorers who went to the Andes. And one of the things that most fascinated the Europeans who crossed Africa was to discover the snows of Kilimanjaro. So the Himalayas, of course, that's central to Hindu religion and civilization, that in most of India is a fairly hot place, that either dry plains or forested, but in the north, just these huge white summits that are the abodes of the gods. They've been part of human history around the world for millennia. And I think we've known that they're there, and we're coming to understand them very differently because of the changes that have been happening at a different pace pretty much in the last few decades, since the 1970s and 1980s certainly is where the main changes have been going on.
Well, how did these glaciers evolve? That I kept asking myself as I was looking at this book.
The glaciers are so high in the mountains that many people think of them as just a permanent fixture, something that's always there, the glaciers have been in place eternally, and it's only now that they're beginning to change. But in fact, they're quite dynamic. They change not at a scale necessarily of month to month or year to year, but give them a couple of decades, and they can really begin to advance. If you get a long series of snowy winters, that means that there's more ice forming on top. And we think of ice as something that's very solid. It's hard. It seems as solid as a brick. In fact, geologists consider ice to be a form of rock. But if there's enough ice, if it's perhaps 40 or 50 feet thick, and if it's on a steep slope, it can begin to flow downhill. So there have been times in history when glaciers have advanced. That's how some of the earliest historical records of glaciers come, is from the people in the 1600s and 1700s who were worried not about glaciers shrinking, but about them advancing. There are these letters that farmers in remote valleys sent to the King of Norway: "Help, the glacier is coming down my valley, it's eaten my meadow, it's taken my barn away." Can you imagine just this wall of ice as it comes down a valley? That's something that doesn't happen overnight. It's not that you go to bed one morning with a glacier at the top of the valley and you wake up the next morning and it's outside your front door. But if it advances 100 meters a year, that adds up quickly. That would be very fast. But even a few meters a year can add up over the centuries. Contrary-wise, if there are periods that are either drier or if there are periods that are warmer, even if there's a lot of snow falling high up in the mountains, enough snow to last year after year so that it converts to ice, there's a lot more melting happening at the lower end. It's that warmth lower down that really can mean the decline, the end of glaciers, because glaciers can form in high mountain areas where it's very cold. The snow falls, converts to ice, and flows down the slope, and it eventually flows to areas that are quite warm. So you can certainly see glaciers in places that don't seem like cold mountains. Some of the glaciers in Pakistan, actually, the Karakoram Mountains have glaciers that travel down into deserts. You can be in dry canyons that look like they're part of the southwest, but down in the valley, rather than being a stream, is actually a river of ice. There's so much ice that's come down. But as those valleys warm, the ice melts year after year, and so the glacier begins to retreat upslope. It's not that the ice itself actually moves backwards against gravity and goes up. The ice continues to flow down. If the ice that's forming high in the mountains will come down the valley, but the edge of it is melting so quickly that the down-flowing ice doesn't get as far. It just melts at a higher and higher elevation until eventually it's much smaller, or in some cases entirely gone.
I thought it was interesting, that, like you were indicating, of differentiating the different kinds of glaciers and where they're located.
There's a whole world of... There's a group of people who study glaciers who are great experts in glaciers, and they are called glaciologists. And they have many different distinctions of types of glaciers depending on their form, whether they're broad, flat ice caps that'll cover a plateau, or they're mountain glaciers, whether the glaciers remain only high in the mountains, or whether they come all the way down to the ocean, to the people who've traveled to Glacier Bay in Alaska. My mother-in-law has been there, tells me it's beautiful, says, Ben, you ought to go. I've never been, hope to see it someday. But those are the places where there are the glaciers that come all the way down to the mountain and reach actually the ocean. And that's, of course, the enormous ice sheets of Antarctica. It come out ice shelves that can extend hundreds of miles into the open ocean. So there are many different types of glaciers. Some glaciers receive a great deal of snow and have a lot of ice flowing down slope, but also melt quickly. So the glaciers in New Zealand, for instance, are in some of the moistest parts of the world. Huge, certainly hundreds of feet of snow falling in the mountains, and so plenty of ice forming, but it goes down into relatively temperate areas, so it melts quickly. So that's a lot of input and a lot of output. There are other places where glaciers form in relatively drier and colder places, so they're not advancing as fast, but they're also not melting as fast. So there are indeed many different sorts of them, and these people who studied glaciers, I should say, for a while were one of the specialists within geology, within geomorphology or geography. They studied these curious features. They developed understanding of how they work. They conducted field research. They constructed scientific models, developed equations that could predict the size and movement of glaciers. And they came broadly into the public attention in the 1980s, when the fact that glacier retreat was taking place in so many different parts of the world came to the public attention. And that's when this became a matter of urgency. It's a little bit like polar bear biologists. Everyone likes polar bears. They're a curious and interesting animal. But the study of polar bears has become much more important now that there's a lot of attention to the melting of the sea ice in the Arctic Ocean. The fact that the Arctic Ocean may be entirely free of ice in the summer in perhaps 2020, not that far in the future, means that we really have to think about the long-term survival of polar bears. Are they risking extinction? So they become more important. And much as climate change hits the areas of high latitude, such as the Arctic, it also hits areas of high altitude, such as the mountains. And so glaciers that used to be kind of scientific interest now are of much broader public interest because they tell us so much about climate change and affect us so directly.
One question I've got is, what do you mean by retreat of a glacier?
When a glacier... There are really three ways of talking about the size of a glacier. You can talk about its volume, you can talk about the total amount of ice that it has. That could be in cubic meters or even cubic kilometers. You could talk about the area, and that's the amount of the Earth's surface that it covers. You can measure that from a satellite, measure it from a map. And you can also study the length of the glacier. How far down the mountain does the glacier come? And that's the thing that people are most attuned to. They're used to seeing a photograph that shows the glacier, and they often come quite a ways down. When you do repeat photography, when you return to the same mountain, sometimes even after only a few years, sometimes 5 or 10 years is enough to show a difference. And certainly going back to the areas that were photographed in the early 20th century and seeing them now, you see that the glacier has retreated upslope, where an area that used to be covered with ice is now exposed. That's of importance for several reasons. One is that it just documents very immediately and very viscerally how strong the change is. It documents it in a way that everyone can understand. There's some scientific changes that really only experts can understand. Some of the environmental problems that are most important to us are ones that we can't see. We can't necessarily see the radiation that was emitted when Chernobyl exploded, even though that was one of the most important environmental disasters of the 20th century. But you can certainly see the glaciers moving upslope. So it's something that's important because people see it. It's also important because the areas that were formerly covered with the ice now are exposed, so among other things they're warming. The bare rock is darker than the ice was, so that means that every summer the sun shining on those rocks is going to warm them, it's going to warm the mountain, it's going to continue to accelerate the process of glacier retreat. It means that water that used to start melting low down on the mountain, a stream that would start low down on the mountain is now starting much higher up. And not so much water is going to get down to the people down below who would like it to irrigate their crops, might use it for hydroelectric power, might even be important for biodiversity, for fisheries certainly. And there's also hazards associated with these changes. If you have ice filling a deep valley, the sides of the valley are going to stay in place. They're held up by the ice in the glacier. When the glacier's gone, these steep slopes can collapse. They can come down the mountain as landslides. Sometimes lakes form in the former valleys, former ice-covered portions of the valleys. Where you used to have ice, the water that's melting might get dammed up behind just a ridge of rock. So these new lakes form, and many of these are unstable. And sometimes they break, and these are the disasters of these floods that rush down valleys, can destroy hydroelectric plants, can kill people. There was one such flood in Peru that killed 20,000 people, took out an entire town of a large size. And there was no time for the people to get away. These are just walls of water and mud and rock and debris that are coming down at hundreds of miles an hour. It's a process that involves many components, because it involves the ice that's forming at the top of the glacier and then the ice that's melting at the bottom. But it's also something that has, in addition to being complex, I'd really like to emphasize that it's relentless. It's very steady and it's very slow, but it continues. People use the word glacial to mean slow. In ordinary speech, you'll say this is proceeding at a glacial pace. If you're trying to get a loan approved, you don't want it to proceed glacially, because you think of glaciers as moving forward very slowly. But the other side of glaciers is how steady their movement is. And so for the people who live near glaciers, I'm thinking of I spent a week in Peru at a really tremendous elevation. This was 15,000 feet above sea level, at a place where the glaciers are just above the village where herders live. These are people who herd sheep and also alpacas, these kind of cute animals you can get wool from. And they're used to the glaciers coming really close to the village and to the streams coming out from the bottom of the glacier. And people can talk about where the glacier used to be and how now it used to be much lower and now it's higher. They can tell what their grandparents told them about how it was really much lower. And so they just see year after year the glacier is higher, the streams are starting higher up, they can point to the streams drying up. They can point, there is the glacier. It used to be here, now it's up there. Do you see this stream that's coming down? It used to be much broader. Do you see this pasture that's right on the edge of the stream? Do you see how this is all dried up? We can't take our animals there anymore. These are things that you can see, and so it's something that has a tremendous impact for the people who live there. For people who travel to glaciers from time to time, people who live at a distance, they might say, gee, I was here 5 years ago and now it's so different. People who go to Glacier National Park in Montana, people who travel there when they were young and want to bring their kids, they're doing a car trip around the country, and suddenly they remember that when we drove here we could see the glacier, and now you stop at the road, you get out of the place where you took that picture, or where the grandparents took the picture, no more glacier. It's suddenly gone. It's way high up, just a little piece at the top of the mountain, and maybe you can't even see it from the road. So there's something about the steadiness of this process. It might seem slow. You might say, well, if the glacier is shrinking a few hundred meters or a kilometer a year, is that really that fast? It's not like we're used to things moving quickly. We live in such an accelerated society. It doesn't take a lot of years for that to add up, and suddenly there's less ice, and not only is there less ice on the mountain, but there's less water down below. And I think that's the thing that really people can connect with very much, very directly and very immediately. They can know that Yes, the glacier used to be bigger, now it's smaller. It used to be very beautiful. We love the mountains for their beauty. We really count on them to just be these wonderful range of white beacons on the horizon. That's one concern people have. But for the people who are down below who are saying, I need this water to irrigate my crops, so many places around the world where people depend on glacial meltwater for irrigation. The most important case certainly is in South Asia. India and Pakistan, literally hundreds of millions of people who tap water that comes from streams in which glaciers contribute a large amount. But in South America, certainly, there are tens of millions of Indian peasant farmers in the mountains, who, many of whom are facing decreasing water supplies. Maybe they're only able to get one crop a year where they used to get two. The glaciers, the water coming from the glaciers could extend the growing season. Or maybe they're having some years where the crops aren't doing so well or even failing, because in years of little rain, you always have the water coming off the glacier to complement the rainfall. Now you have less water coming off the glacier, and maybe you have less rain too. That's another consequence of climate change. Those can interact. There are parts of the Alps where people irrigate with glacial meltwater. And you think of the Alps, you kind of think of them as very green. You think of, when you think of the hills being alive with the sound of music, you also think of Julie Andrews tripping through the meadows filled with edelweiss. But there are parts of the Alps that are kind of dry. They're on the dry side of the mountains. They're deep valleys where the rain might be concentrated on the higher slopes. So they want that meltwater coming off the glaciers down into the valley, and that's how they irrigate their crops, their grains, certainly the vineyards. The hydroelectric power is another important use of glacial meltwater. You have the water that comes from glacial melt often appearing in the rivers in the summer, because that's when the highest temperatures are. So you might have more rain in the spring. You'd certainly have more melt of the snows in the spring. That's something you're certainly aware of here in the Midwest, is the flooding that can occur when the snows melt. But the glaciers contribute water during the summer, often a critical season, often a season of high demand for hydroelectric power. And so the people who are managing the dams, the ones who release the water from the reservoirs to generate the hydroelectric power, may be faced with a very severe constraint, that there is less water.
So all these dynamics, I was remembering you were talking about the cultural landscape, how glaciers change practices, about what's happening.
It's interesting. When I think of cultural landscapes, there's one image that comes most sharply to mind, and that's of a pilgrimage that takes place in highland Peru, near the city of Cusco, where thousands, literally thousands of people walk to the base of a large peak, a peak that has glaciers on it. They camp there, and at night they climb up, and they climb to the face of the glacier, and they cut off ice. They carry the ice down on their back, and they save this ice. When the ice eventually melts, they wrap it up so they can take it home. When it melts, this water has medicinal properties and just kind of is associated with the power, the kind of spiritual or religious power of the mountain, and in a way also with the act of service to this mountain spirit that was performed by carrying the ice on their backs. And so this is something that people had done at least for 200 years. It's well documented in the archives going back not only for the entire history of Peru as an independent nation, but back into the times when the Spanish ruled Peru. And it's certainly associated with other kinds of practices that the Incas, the early civilizations in Peru, carried out. And this is a practice that stopped in the year 2005. The people who hiked to the glacier year after year noticed that they had to walk further and further to get to the ice, to the point where this act of service, this climbing up the mountain at night, and then when it's quite cold, and then climbing down with this piece of ice on your back, that was something that became more and more difficult. And finally they became troubled. Why was the ice shrinking? From their perspective, the mountain spirit was no longer giving the ice to the people. The mountain spirit in that sense wasn't receiving the respect, the prayers, the offerings of the people. And they tend to see this as a sadness rather than an anger on the part of the mountain spirits. And they decided they better stop. That if they continue taking the ice, that might create even more displeasure on the part of the mountain spirits. So what they now do is they go to the little ponds that are lower down on the mountains and the streams. These are places where just a thin layer of ice forms at night. Temperatures will drop into the teens, and you can just get a thin layer of ice and you can break off a little piece of that and have something to take back. So for these people, this is an enormous distress. It's something that seems really wrong to them. I just would want to add that it's easy to say, well, those are Indians in Peru, those are people who kind of have a more magical or spiritual view of the universe, and those of us who live in modern societies are just more sophisticated. We have a more scientific view of the world. We really care about the material resources, maybe not so much about the spiritual world. These are people who are around the world. People care about glaciers also in a very deep kind of way that I think for anyone who's ever traveled to Seattle, who's spoken to the people who live in Seattle, knows that Mount Rainier is just an icon to the entire population. It's an area that's with a lot of cloud, a lot of rain, a lot of gray. When you get those few clear days when the sky is just that soft blue that it can be in the Northwest, I mean, Mount Rainier is just enormous, jumping into view on the horizon. People just stop and look. They're busy, they're on their way, and they're just looking at the mountain, taking it in. And there's something so big and noble and pure about the mountain. That's kind of what's special about the Northwest, even as it's an advanced area, a very progressive area. It's, after all, where Microsoft is from. It was a leader in aviation, and it's a high-tech area, and yet it's a very clean and pristine area. The thought that Mount Rainier is endangered is just as disturbing to the people in Seattle in their own way as the changes in the mountain in Peru is to the Indians who live there.
I think it's that sense of place when you live intimately for a long time, thousands of years in one place. You take notice of the major elements. I thought it was interesting that in your book you were talking about the first and second lessons that glaciers had taught us. The first lesson being the dynamic quality of the earth.
No, it's kind of a turn of phrase, and certainly the early 1800s was a time when people were discovering that the earth was dynamic, that this was really a time when the narrative of Genesis, of kind of the creation of the earth and the flood, was beginning to be replaced by modern science. That's the period when archaeology was beginning, when the fact that previous cultures and civilizations left remains that could be dug up out of the earth, that came into view. That was a time when fossils were discovered, and it was a whole question of where did these fossils come from, and they showed how old the earth was. And then there's a question about what are all those scraping rocks that have lines scraped on them? What about these boulders that are just out in the middle of meadows? And that's when the geologists began to discover that there had been this thing that they termed, at that point, the Ice Age. The fact that there was a time 10,000 years ago when ice sheets were much larger, covered much of the earth. And that, in fact, is true of where we are here in the Midwest as we sit here and converse. This place was once under a lot of ice.
One of the natural questions that comes out of this is, what's it going to be like in the next hundreds of years? Are we going to have waves lapping at skyscrapers, as you pointed out in the book?
The waves lapping against skyscrapers is yet another piece of yet another of the impacts of glacial retreat. Oceans are rising around the world. They rose 6 inches, 15 centimeters in the 20th century. And of those 6 inches, it's basically 2 inches coming off mountain glaciers, 2 inches coming off Greenland, and another 2 inches because oceans expand just a little bit as they warm. That 6 inches doesn't make a huge difference. It means maybe there's a little more frequent flooding in coastal areas. They're expecting about a meter, 3 or 4 feet of sea level rise in the 21st century, in the century we're now living. And those estimates keep increasing, and that's enough to make a difference. That means that low-lying airports in coastal cities are going to close more. That means that the sewer lines that cities build to discharge, expecting the sewers, or the sewer treatment plants, we hope, to discharge above sea level, aren't going to discharge because the sea's risen and the ocean's going to back up. And whoops, we better rebuild our entire water disposal system. These are big expenses. So it may be more than a meter in the 21st century. We're still early in the century. We'll see how that proceeds. What happens beyond that is difficult to discuss for 2 reasons. One is that it's very hard for us to think that far in the future, the time when even our grandchildren will no longer be living. And it's also because what happens then depends on the steps that we take now and that society as a whole will be taking in the coming years. An important meeting happening in Copenhagen in Denmark this December that's going to set up the whole architecture to replace the Kyoto Protocol. So we hope that they take good steps, steps that the whole world can say, yes we can, yes we must take these steps, that they can begin to take those steps. If they do, then I think the warming will slow down, it will be serious, but not completely devastating. If we ignore this opportunity, it'll just get harder when we have to take bigger steps later. And glaciers are one of the pieces that are helping us say, yes, we better make those decisions now.
I keep thinking that one of the important things, and you suggest this in your book, is that we need new patterns of consumption. We can all do something, at least that much. And also, that new technologies can come into play, including the green technologies, so they'll help. But it is a pretty awesome thought about what could happen if nothing is done.
Steps that people can take, and one that I've taken, I'm certainly not going to mention any particular brands, but I've stopped drinking sparkling water that's been imported from other continents. It really makes no sense to air freight water that could just be carbonated here in the US to bring it here. And I think there are a lot of small steps people can take, and the hope is that these steps that people can take that are simple ones, the compact fluorescent light bulbs are another favorite example. These are steps that people can take, and the hope is that this will lead people to take further steps. You could always worry that people say, well, I stopped drinking my imported sparkling water, or I fixed my light bulbs, I'm done. But I think as people take steps, they learn and they just become more aware, and the hope is that these steps will spread and also that new technologies will take place. Hybrid vehicles, who would have thought that these kind of hybrid gasoline electric cars would do as well as they would, and we're seeing that different countries are trying to move into that market, recognizing that demand is going to grow for them around the world.
I think we need to take the Native American view of looking so far in the future that we're talking about our children, our children's children, on down the line. It's not just what we can get for ourselves today, but it's what we can leave as a legacy for the rest of the people.
Well, there's really the sense that that people can have that sense of attachment to their neighborhood, to the area that they live in, that they live close to. And again, that example of Seattle and Mount Rainier, how the people in Seattle care about Mount Rainier because it really is special to them. It's really one of the national treasures. We would feel awful if all the original copies of the Declaration of Independence and the Constitution disappeared. We'd feel terrible if the Liberty Bell somehow was stolen. And I think we can feel that way about our own mountains in the western United States, and I think all of humanity can feel that way about our planet, and the glaciers really help affirm that connection.
Thank you for being on Rip Rap. This is an important book.
Thank you very much. My pleasure to be here.